So, good afternoon, everyone. Thank you for being here today. My name is Juan Sanchez, and I am thrilled to present to you the Phoenix Project. The Phoenix Project has been an ongoing initiative since 2020, and as we approach its completion in the coming months, we are excited to share with you the remarkable progress we have made. I will delve into the methodology employed, the platform we have built, the services we offer, and most importantly, the impact of these projects has had on our demo sites. So first, this is an introduction to the project. There is one challenge. An important part of the Europe's clean energy transition is to see the role of buildings from energy-consuming entities to structures that are conscious, often responsive to the occupants and their environment. So the idea is to transform an unconnected building into a smart and connected building, and with this to provide a smartness hub based on ICT with modular components to integrate different equipment, different devices, and consider all the context data in the platform coming from different buildings and different external sources. What are the objectives of the Phoenix project? First, seamless adapt and play. The idea is to easily be able to connect one device, one equipment, one external source in a useful way. Use for that innovative technologies, like for example the NGSI LD API, and other protocols from IoT like MQTT, another useful software technologies for the dashboard, and so on. Also, we have another objective is the real-time communication. We will manage a lot of devices, a lot of data coming from the from the real from the physics layer, and we need to ensure that there is a real-time communication to have all the data in a proper way. Also, we have another objective is to have an human-centric approach. One of the end users of Phoenix project is the building occupant, so we have to take into account the comfort of the services, the comfort of the users, the requirement of the users, and their preferences. With this platform, with this solution, one of the objectives is to provide cost-effective services around this platform, and also considering the security and building privacy. As I remember, this project started in 2020 and will finish this year. Although it has been extended 3 months. And we can see here some of the partners, even UBTech, it is also here, and the demonstration cases in 5 pilots from different countries like Spain, Sweden, Ireland, and Greece. Okay, this is the whole consortium of the Phoenix project. And this is the more details about the pilot realization. We have a Greek pilot case, named Kama, Swedish pilot case, and Choose pilot case, Spanish pilot case, and the last one is the Irish pilot case. We can see here that we have different buildings with different characteristics, with different locations, and with different weather conditions. So we have many scenarios to test, to validate, and to demonstrate the Phoenix solution. What is the mission of Phoenix? Phoenix will provide a portfolio of ICT solutions. What is the goal? The goal is to increase the smartness of the legacy systems and appliances existing in the buildings, which will increase the HRI and energy efficiency. When we say SRI, this is the Smart Readiness Indicator. This is a common US scheme for rating the smart readiness of buildings. The purpose of this indicator is to try to evaluate the smartness of the building. So we, in Phoenix, we use this indicator to compare the different buildings before and after the interventions. There are many key objectives in Phoenix projects. For example, as I commented before, allow a data and play seamless integration of domestic appliances, legacy equipment, and building systems. This is very important because we can see that there are heterogeneous devices in different buildings, so we need a solution to try to have we have to try to have all this data in a common way. So we need to integrate these appliances and try to reach the homogenization of the data. Another key objective important is enable the real-time communication with the energy stakeholder to optimize the grid operation. In Phoenix, we consider the communication with the grid. We have a business stakeholder interface, which includes a user interpreter to try to trade flexibility with the external agents of the grid. For example, the aggregator, the ACE codes, or the grid utilities. Another key objective important is to provide cost-effective services for building and user. The services will be presented in the next slides. So what we need to reach these key objectives, we need software, we need a platform, we need hardware, very important because we need devices to measure or even to actuate over them. And we need to demonstrate that this solution can be applied to all the pilots and extract the draw conclusion of these interventions. So what is the Phoenix solution? The Phoenix solution is a smartness hub based on ICT. This solution includes user-friendly and cost-effective services adaptable to the specific needs of the building, users, and grid utilities. As we saw before, we have different buildings with different requirements due to the weather condition, due to the user preferences, or whatever. So this solution considers several impacts. For example, the first impact is provision user-friendly services to the building occupants, minimization of cost for a building upgrades into smart ones, increase energy savings, achieving grid flexibility, and easy flow of information between users and stakeholders. We can see here the architecture of the Phoenix platform. This is the Phoenix solution, the Phoenix Smartness Hub. We can see that this platform is divided in several layers. We can see the first layer, the under layer is the asset layer. This layer contains all the devices, all the equipment installed and deployed in the different buildings. Also, we consider here in this layer the external data sources. These external data sources can be the weather condition, can be the information from the energy market, like prices, like CO2 emission, and so on. And we also consider the integration of existing buildings management systems to have all the data integrated in the upper layer, the integration layer. This layer is in charge of storage of the data, format the data, and give a context meaning. I mean, in this layer, we have the two more important components, real-time data broker, who stores the real-time data, and the platform data repository, which stores the historical data. There is another upper layer. This is the knowledge layer. This layer is in charge of enrich the context data coming from the under layers, and in this layer, Phoenix applies several analytics tools centric in users, in grid, and based on AI. And there is another layer upper this knowledge layer. This is the function layer. This layer includes all the services available in the platform. We can see demand flexibility management engine who provides the functionality for demand flexibility. We can see self-consumption optimization engine who provides the self-consumption service, and so on. And there are two boxes in green. This is the interfaces with the business layer. We can see the business stakeholder interface, which includes the communication interface with the grid, and the building occupants visualization dashboard, which includes the graphical interface to provide the access from the building owners and building inhabitants to the platform. So there are two entry points to the Phoenix platform. First, business stakeholder interface from grid utilities, from ESCOs, from aggregator, and another one, this is the graphical dashboard for end user like building owners and building occupants. Okay, to summarize, I will try to summarize all the services available in Phoenix project. First of all, we have the dashboard. As I mentioned before, the dashboard is the entry point to the platform. From the dashboard, we can see the result of the services. We can see their measurements, our energy consumption, our energy generation, and so on. So this is a key entry point for the user. Visualize all the information coming from the Phoenix platform. And another service is the self-consumption optimization. The users are able to be analytics regarding energy consumption and regarding energy production. We can see some EV chargers, EV charging schedules that the smart service proposed to the user, leading to optimizes EV and battery charging. Another service is the comfort and well-being service. This service consider all the information coming from the sensor, like CO2, like temperature, like weather conditions, and also consider static data coming from questionnaires to the user to know their requirements, their comfort requirements. So this service is able to provide a smart notification to the user, or even control the air conditioning in an automatic way to meet the user requirements, the user comfort requirements. Another service is the flexibility. The Phoenix provides the service for grid flexibility. Phoenix is able to communicate with the grid and provide a solution to perform demand response events, and even is able to extract the data coming from the energy market and create demand response events to shift the load from high expensive periods to low prices period. Even we consider the CO2 emissions to be able to move the load from periods of high CO2 emissions to low CO2 emissions. Another service is the Smart Performance Assessment and Advisor. This is the service in charge of evaluate the smart readiness indicator. As I commented before, this is an important indicator in the project, because it is used to evaluate the smartness of the buildings and how the solution can evolve the building from a old building to a smart building. Another service is the energy performance certificate. This service is able to estimate the energy performance value, analyzing the consumption during the heating and cooling periods, taking into account the temperature and so on. There is another service called predictive maintenance. These services evaluate the operation of different devices, for example, generation devices, and study and analyze their operation to to provide alerts for potential malfunction, allowing critical failures to be proactively addressed and repaired in advance. We can see here one screenshot of the Phoenix dashboard. This is the building occupant view, and we can see here on the left the different services offered to the building occupant: self-consumption, occupant's comfort, and smart readiness. We can see here also the EPC values. For example, we can see that in this building, this is a level. And we can see here, this will be the building manager view, who has access to the rest of the services and also to the flexibility services. We can see here that the building manager can configure the parameters for flexibility. We can see here that the building manager can set the time window and the compatibility factor of every device. Okay, to summarize, the services and the pilot sites of Phoenix, we can see here what services we offer to different pilot sites. As I commented before, there are different pilot sites with different characteristics. So, for example, in the pilot sites, I remarked that in Phoenix we provide the blackout support using the device, sorry, the energy storage device, and also the optimized EV charging. We offer also in the grid pilot the grid flexibility through the control of the energy storage device in a smart way, and also sending notification to the occupants informing about the demand response events like a grid signal or maybe high prices periods or whatever. We can see another service to remark that this is the Spanish pilot site 2. In the Spanish pilot site 2, we use the HVAC for grid flexibility, the flexibility service control in an automatic way the HVAC devices to reduce the consumption in the desired periods. We can see that also for the comfort and well-based service, the ventilation is controlled for comfort and convenience, and another services that this is in a similar way. So I don't want to repeat more. Okay, regarding the demonstration activities, we have 6 objectives. One objective is improve the efficiency and energy management of the building, enhance life quality and comfort field of the occupants, decrease the cost of the energy, demand response and flexibility for grid optimization, consumer to prosumer transition, this is very important thing, and data for building intelligence. This table summarizes more or less the different pilots and the different characteristics. We can see the different typologies like residential and non-residential buildings and with different location. And we can see in the last row the HRI score after all the interventions of this Phoenix solution. We can see here also the improvement of the HRI indicator in the impact of the HRI indicator, and more details can be seen in this article, in this journal article. Okay, finally, I am going to summarize the results and the impacts of the Phoenix solution in the different pilot demo sites. For that, we Phoenix defined several KPIs, key performance indicators, to evaluate the effectiveness of the solution. For example, we can see here the first KPI, this is energy performance measure. We can see that these values for the heating and cooling period in the Spanish pilot site, this is applied also for the rest of the pilot sites, but I only wanted to show one of them. Another KPI is to prove that the smartness of building and a smart readiness indicator is improved. So for that, the smart readiness indicator was evaluated before and after the intervention, and we can see here the values, how the SRI increased from the before and after the intervention. Another KPI is the possibility of shift the load and the demand in the buildings, applying the variable tariff scheme. So we can see here that in after analyze the results in our trial in different buildings, we reach 31% of demand shift from high cost period to low cost period, even at 36% of energy cost reduction. Another KPI similar that the commented before is the load and demand shifted from periods of high renewable production. So the result for that KPI was around 30% demand shifted from low renewable period to high renewable period. And the last 4 KPIs, one important KPI is the target energy savings. We reached 35 energy savings in one of the Spanish pilot sites, even 51% of energy savings in another Spanish pilot site. And to remark, also the blackout support for specific loads with over 90% of reliability. We performed some tests in the Greek demo site, and these tests reach 100% of reliability. And that's all from my side, from Phoenix project. Maybe if you have any question, or maybe at the end of the workshop. Thank you, everyone. Thank you, everyone, for listening to me.
Thank you, Juan.
Yeah, if okay for all of you, I can go next with the presentation of a BuildHub project. Is that okay?
Yes, of course.
Okay, then let me share my screen. Okay, please let me know if you can see.
Yes.
Yes.
Okay. Yeah, I'm going to present you the BuildHub project. I'm giving an introduction, and then I show main results. And there will then be a more in-depth session afterwards regarding the BuildHub web-based platform that we developed, which will be presented by Jose. So I'm Ulrich Felipe Oberger. I'm the project coordinator of BuildHub. I work in Eurac Research, which is a private research institution in the north of Italy, focusing on renewable energy in buildings. And I'm in the energy efficient buildings group, and specialized in occupant behavior, analyzing building energy performance data, and as well in building energy control algorithms. For this workshop, I created a brief overview of BuildHub with the main results. So this project is a 4-year project. We are now in the 3rd year, and it will be finished in September 2024. The main goals of the project are to develop a roadmap for constant data flow to the European Building Stock Observatory. This observatory basically collects data for each member state in Europe about the building stock in their state and the energy performances, but also general data like number of buildings, floor areas, renovation of buildings, construction, demolition of buildings, and so on. So we wanted to help and support the further data collection for this observatory. We did this also by creating and engaging with the community and understanding what the data collection, exchange, and data to knowledge processes are, what barriers they face, and how these barriers could be overcome. Then we looked into standardization of data governance and services. One of the main issues faced is oftentimes that data needs to be harmonized, or that is difficult to understand what data represents, and that data might even not be accessible in the first place. So we tested such services in a web-based BuildHub platform. And finally, we did some coordinated action among similar projects. This slide shows a bit the idea. So we have the community of data providers, of users of such data, and a platform on the other hand, where this data goes in and is visualized and can also be downloaded. There are several associated projects dealing with big data, providing use cases. And finally, the enriched data is thought to be fed into the building stock observatory, along with many other databases from other projects, as well as, of course, national statistics databases, Eurostat, JRC data, and so on. Yeah, we created therefore a community which is divided here by organization type and geography. So we could obtain quite good spread over Europe of organizations involved. We also obtained a fairly well distributed diversity in organization types. We have the main share in academia working in this field, and then we have several sectoral other organizations. Of course, we have public administration, we have energy agencies, as these typically deal with this kind of data, and then policymakers, financial institutions, and so on. Yeah, we in the beginning of the project, we compiled different data sources. These data sources relate to either the building stock itself, to socioeconomic data, or to climatic data. So while category A, the building stock related data sets are the core, of course, this oftentimes needs to be associated with socioeconomic data and climatic data to give a full picture. We used as data sources different EU projects. We used official national statistics, as I mentioned, and of course also some other aggregators of data for climatic data, and also data on, for example, distribution of solar irradiation and so on, which can be helpful for understanding the performance of buildings. We then also created a building data platform, which was our testing environment, to understand how this data can be represented, how it can be made useful to stakeholders, and how stakeholders would interact with this data. So we created several graphs and also so-called stories, where we guide the stakeholder through specific information, showing how different data sets can be compared for the same indicator, showing or allowing the stakeholder to evaluate which data set might be more trustworthy, more reliable. And there's also a section on guidance for machine learning models that can be used with certain data sets. We also work on a roadmap for the Building Stock Observatory, which is undergoing different iterations. Right now, it is in a new phase where the European Commission is revamping the observatory and asking for further data and doing a push also with the EPBD recast directive and so on. So what we have here is a kind of a bird view, what should happen optimally in a 3-year time frame in different dimensions from political to environmental. And of course, there is then a deliverable in the project where everything is broken down and more in detail. The roadmap is given with the single steps that should be taken in each of these for each of these dimensions. Yeah, so I'm coming to an end for this overview on BuildHub. As I said, my colleague Jose is then going to go into more details for the platform afterwards. The resources, the main resources that I invite you to check out are the project website for the project, of course, where you can find many of the resources, so events taken and publications, as well as the data platform that you can register to and then check out in detail. This is our consortium. And yeah, I remain available for any questions. Thank you.
Thank you, Felipe, for the introduction and the information that you provided for the project. I'm Jose Manuel Garcia, the project leader of the technical part of BuildHub, and I will start sharing my screen if you don't mind, Felipe.
Yeah, I'm going to stop sharing. So here you go. Should be able to share.
All right. So we don't have too much time to display all the functionalities of the platform, but I will summarize most of the actions that we took in order to design a platform that will cover most of the functionalities that Felipe talked at the beginning. So starting with the introduction, very briefly, as my colleague said, that the main objective of this platform is to create or define a standardization of the data management. It means that we need a reliable source and reliable analysis of all the data that is coming from the building stock, the harmonization of all the data, and to an easy way to treat and to get results in order to validate all this data is one of the main objectives of the project. Second one will be establish a community that can sustain and can endure a live platform. Nowadays, with this type of platforms, that they are very reliable on the data that is being inputted, or is being drinking of, the creation of a community that can, let's say, apport data or give data to the platform in order to enrich and in order to represent these results accordingly. Secondly, filling the gap from the second option that I said, we have in mind to create a robust IT infrastructure in order to being able to scale up, or being able to create a very durable tool that will be live, getting refreshed from the feed of data coming from different resources, being able to adapt and to create a stable and dynamic platform where no matter how much data is coming through and is being processed, is not going to, let's say, crash. And finally, one of the main, objectives of the platform is to be able to transform and to be able to represent this data in order to create opportunities for studies, for new developments in machine learning, and for being open to collaboration, so other web page or other platforms in the future, as my colleague says. Let's start very briefly. We will talk about a little bit about the infrastructure. I'm not going to go too deep on the technical part. Let's say that we originally we decided to go with Amazon Web Services as a whole platform, where all the services that we need will be there. This platform is fully cloud at the moment and can be scaled depending on the resources assigned. So very standard process of data that we can see nowadays in very similar projects where we have data ingestion. We receive data from multiple sources, we digest this data, and we transform and to let's say modify the data that we receive, and then represent this data into something that is feasible and can obtain results. The final version, we see previously the prototype, and this is currently the main structure that we are using. We are keeping the main elements that creates or has Amazon Web Services, with all a whole new set of balancers and availabilities, and mainly the creation of these microservices. So these microservices will allow us to scale up the platform in case of need. Imagine that we have a project coming in, and the amount of data, the raw data that is coming from external source to the platform is too big. We create these kind of microservices, this kind of internal machines that will allow scale up the project very easily. Moving on, and very briefly talking about security. Previously, my partner displayed two links. One of them is the web page itself, which is buildhub.eu, and the other link that he displayed is the link for the platform. Right now, the platform is going to be live very soon, so everybody can access to visit and take a look of what we have done, and take in case in necessity if you need to address or enter this information. We just need to register with an email, a password, all the data that is being received from the external or from any entity that can access to the platform will be a store, and we will process accordingly to the European laws of data compliance. And we like to let's say, according to this registration, we created two different kind of roles. One of them is the role of the contributor. This contributor is the main source of data, has a different type of access to the platform, where he can query information from the database. It can display or it can modify the data catalog, or even do queries to the API. And on the other side is the role of the manager, or is in addition to the capabilities of the guest, it can also administer the whole system, the whole services. So very clearly, we have a contributor or the manager. Everybody that registers right now in the platform is going to be a contributor, so we can play through the system and to test it out with a very simple methods. There are multiple inside the platform. There are multiple, let's say, videos and manuals that will allow you to understand what you are doing. But basically, it's very simple. So let's go with the functionalities. Let's take a peek of the first functionality, which is the ontology viewer. This ontology viewer will allow us to represent using a web-based system to represent the data and into tiny objects. This data will be linked between the data catalog references, the vocabulary, so we can have an understanding, a visual understanding, where the data is coming from, how it's being processed, and which vocabulary has been, let's say, associated to this blob of data. Very simple. We can apply filters. We can disable or enable different types of modes depending on the information of the data what we want to represent. very easily we will see that if you enter to the platform, there will a complete vocabulary or complete guidance of how to understand what this is being displayed on the platform. Secondly, a very brief explanation. We created a specific data catalog for this project, mainly because we are receiving, as you can see, different data sources. So each one of these data sources will be let's say, link or associated to a specific expression or a specific data set in our database. So some of the projects, some of the information that we took from the European community are totally public, that can be accessed to anywhere from the world. Most of them coming from Eurostat, and you can see some web pages or some databases coming from Horizon 2020, and even some private, semi-private, public, like Census or Edgar. So all in all, this is where all the resources, all the sources of data we are taking in our platform. So mainly, if you are curious and you need more information about where the data is coming from, feel free to ask. We will be able to answer every question. For now, just to see a list of mostly the biggest contributors for the data sets of data sources that we have on the platform. So as I said, the creation of this data catalog will help us enable to understand and to treat the data accordingly. We will create these ranges, these data types or content where we understand and we catalog in a specific manner all the data that is coming from external sources. With this process of this identification of each one of the data roles inside the data database, we will be able to understand and to be able to, let's say, create a very clear image of where, after the processing of the data, where the data is coming from, to make relationship between different data sets and to be able to represent it in a helpful manner. Other than that, we also implemented something that we call is SparkQL editor. SparkQL is a semantic query language for databases. It's not very user-friendly, but most of the researchers are using these kind of languages in order to create or in order to process huge quantities of data according to their demand. So this is a open lab, let's call it that way, where if you have the skills to understand these languages, SparkQL, you will be able to create queries to process the data in a very, very personalized and specific way. The idea behind that is that we can be adapted to different kinds of data representation, to different kinds of data resources that we get, and to combine all that different data into a simple matter. Nowadays, is, as I said, only used by people that they have knowledge of the SparkQL language. For the rest, there are other methods of uploading data that is very, very simplistic, as I will mention right now, which is the basically upload into the platform an Excel file with a specific format. There are multiple formats that they are compatible with this method, and just input all that information from that file, just select the file, upload it, and the system will do the rest. All the assignments of the vocabulary, even the representation of the data that is depending on the heading, and it will create an automatic graphic that will help people without knowledge of SparkQL language. Other than that, we have other options of getting data to the platform itself. The first one is through the integration, of course. We develop a very simple, multiple ways to let's say, to process through our API. process data coming from different resources. We are talking about the possibility to get feed of information from URLs, getting feed from information from different platforms, so using a specific method of transmission. We can use OData, we can use archives or files like JSON, CSV, or TSV. But the end is being able to ingest, get data from different resources without getting in consideration that you don't need too much knowledge about it. Most of our researchers are inputting the data through this way. Just pick up a specific Excel file, which is very commonly used nowadays on research, get the headings correctly, to get the data organized, and just put it in the platform, and the integration and the API will do the rest. It will process the data, it will represent it into different manners. So at the end, is all about visualization. So let's take a quick look about some of the dashboards that we developed for this specific project. We will see some of them. This is the list of all the dashboards and storylines. If you are inclined to know more about these dashboards, because there are a lot of them and there are different layers to display this information, just feel free to register on the platform. Let's go through the main ones, the both a variety of dashboards that we choose. As you can see here, all this is a visual representation that the platform itself is just a screenshot. So we can choose between different filters on the left. You see the country, you see groups, years, indicator names, and the sector. And we will be able to apply to these filters and to represent automatically the information. So as you can see, this information, as well as creating a table where all the information is displayed, we have a graphic representation on the bottom right of the corner. And we have also, because some of the data that we process has some GIS information, we will able also to represent graphically on the map the information regarding, for example, in this case, the CO2 emission. So, for example, if we tag the data coming from Germany during the 80s through the 90s, for example, to CO2 emission, we will be able to tag and represent graphically this data through mapping. As you can see here, there is also a different graphics like bars and average information that they are very common nowadays, very easy to understand. We have the filters. We can apply different filters, as I said before. For example, if we want to pass from data that is coming from, I don't know, the country of Greece, we can change the type of measurement element from, I don't know, CO2 to, for example, waste disposal. Keep in consideration that all the data that is being processed it has a specific visualization. For example, we can combine CO2 emissions with kilowatts of energy creation, but we cannot link data that there is no physical connection, there is no logical connection. Other than that, there are multiple graphics that will represent with bars, with a line. And this is a tiny example of the geoinformation sample. So in here, we will be able to, for example, in this case, these are energy efficiency. So right now we are seeing on a grid on the European scale, according to the data that we took from public sources, we represent a color depending on the severity of these, for example, CO2 emissions, these waste disposal for construction buildings, or energy consumption or energy efficiency. The representation with a color can be used as a macro visual representation. We can see the whole country represented by a unique color, or we can even narrow down and to focus and zoom in into specific area like provinces, like, for example, neighborhoods, municipalities, or other, depending on the GIS information that we do from the data. So simple as that. And as I said, there are also the options to represent graphically these renovation graphs. In this particular graphic, we see the energy consumption by construction in a very specific country separated. We have the graphic on the bottom. We have the every country information that we took. We will be that representation. We also see the average line. Very simple representation that nowadays everybody use with other tools, but in this case, this representation is completely handmade. Handmade, I mean, artisan made, where you are the one that chooses how the information is being represented, depending on the information that you are providing. Other than that, this is a tiny example of a storyline of burial, where we can see, depending on the number of housing units, the average floor area, and energy consumption, and reduction of potential for district. So here we are representing districts in a specific city, and we can narrow down and to represent and to analyze different metrics. For example, we can see the reduction of potential kilowatts per year. We can see the energy consumption and percentage. We have the reduction that has been made through the years. If there is an increase, we will be very easily, very quickly understanding how the data that is being processed is being converted and to represent a case study or information that will provide additional information after this analysis. So other than that, I will stop a minute to talk about, for example, the Swedish case, where without the help of machine learning algorithm, in combination with the data catalog and the data vocabulary, and the multiple ways of data integration, we will be able to accomplish what we call it is a Swedish case, which is understanding of how big was the impact between the renovation of buildings in a specific country. In this case, is Sweden, where all the buildings were mostly built during the 50s and the 70s. So all the massive, let's call it that way, renovation of buildings that has been happening to the country through the years to adapt to new regulations, to be more energy efficiency, has been analyzed and through machine learning algorithms in order to represent how was the impact of this renovation through using data coming from Sweden. So as you can see, we can adapt the dashboards and the information very easily, very quickly to projects, to collaboration, or just simply to data analytics for research in order to do, for example, a PhD. Finally, some documentation and storyline and guidelines, as I said, inside the platform. Feel free to register. I say it again, feel free to navigate, because every part of the platform is very, very, very user friendly, and we try to create videos to navigate through the whole system. And that's it. So feel free to contact us if you need something. For now, that's all the time that we have for today. Thank you all.
Thank you all. So I suppose that I'm the one that has left. Thank you for the really nice presentations. And let me share my screen. Okay, why I can't. Okay. So we'll start with enter here. Okay. Perfect. I suppose that you can see now the presentation in full screen.
Yes.
Yes.
Perfect. So we start with a very small overview of the project. It's a project that started at the end of 2020. It is going to last for 36 months, and now we have actually left around 6 months to complete the project. And there are 13 partners involved from 8 different countries. Actually, the main domains that the project addresses is first of all buildings and energy systems, big data analytics that are applied over the buildings and systems, and any business innovation and markets that are involved in some scenarios. The pillars, at least for the buildings domain, that we have stepped upon are decarbonization, decentralization, and digitalization. What we want to achieve is to control devices at the edge and also have achieved huge data production, because we have spotted an issue on data silos and actually minimum quantities of energy related and building related data. And of course, some meshed network of stakeholders, at least these are the most of them that we're working on. And of course, how we can penetrate more decentralized energy resources. And now that photovoltaics, especially, have been increasingly installed around Europe. So basically, the flow in Beyond is centralized over the data consumers and the data providers. This means that from a data provider aspect, the extraction of data is a very important pillar to be sure that that the data that we extract are secured throughout the Beyond platform and the way they are shared between consumers and stakeholders. And then from the part of the data consumers aspect, it is very important to be sure what are the reasons of and the use cases of using this data, how they are going to be exploited, to add some intelligence on the buildings and the system services based on this data, and then explore and analyze new possibilities for the buildings and energy system sectors. Some of the novelties that Beyond is trying to implement are first of all data management tools and technologies that actually facilitate the extraction, transformation of data, security, anonymization, everything. The data exploration from the part of the consumers, at least, the data consumers, having a descriptive and full catalog of different energy-related and building-related assets, and with them to provide analytics as a service, and interoperability between different sectors. As mentioned before, security and privacy are also very important in Beyond platform. And also there are environments that any executions can be over data, and calculations um, can be applied in a way that that everyone has the results of the calculations and everything available even at a decentralized way. And of course, data sharing, as also was mentioned, between stakeholders. And in some cases also extra control activities over the data and the assets. Some actually of the stakeholders, to be honest, that is important to keep in mind that plays an important role in beyond are ESCOs, retailers, network operators, of course, and aggregators. And then from the other side, of course, we have prosumers. For each of them, there are a bundle of different services that are offered. For example, to aggregators, there is a possibility for having a tool for a VPP configuration, virtual power plant, for demand response reasons. For prosumers, of course, it is important for them to have a way to visualize and have very interesting and useful insights over their energy consumption and generation. So there are different energy analytics and the automation actions to provide it. And another good example is the advanced renovation support, mainly for predictive maintenance, that can help ESCOs to offer different energy services to their customers. There are 4 different demos involved in Beyond. In Greece, Mytilineos, which actually is already testing the Beyond platform from the retailer perspective. And also they offer data from their new smart buildings. Spain is the next demo partner with Cuerva and Urbener. One of them has the role of a retailer and the other of an aggregator. In Finland is FVH. Mainly, they care about building management. So they are offering both residential and commercial buildings. And Serbia, with Beoelek, they are mainly focused on district heating from the part of the buildings, but also for retailer services. So some of the aspects that are covered from within these solutions is the storage of the data, first of all, and then the data exploration and retrieval for the consumers of the data. Data trade in case that there are some restrictions on the way data can be shared between stakeholders, data analytics that are built upon them, and some of the tools that are developed under Beyond platform are the impact assessment tool for energy policy making at urban level, then the district heating and cooling optimizer, the distribution grid planning and infrastructure sizing tool, the renovation optimization support tools, the building digital twins environment, the building portfolio management optimization, and the personalized energy analytics tool for guidance on energy performance optimization and human-centered control automation. Today we're going to show you some slides of the 2 last tools and their usage and how they are going to help their respective stakeholders. There are also the energy performance and smart readiness certification tool, and the flexibility-based VPP configurator and demand response strategy optimization tool. This is it for the general overview. And now regarding the two different tools that we are going to present to you in more detail. We'll start with the BPMO tool, the Building Portfolio Management Optimization. The main goal of it is to develop and present actually a tool for retailers so that they can have a very good overview of their portfolio through some analytics and statistics with information that can be intuitive for them on how they can handle their portfolio and their customers. And another important part of the tool is the part of the implicit demand response through some different pricing, dynamic pricing calculations that can help to reduce the demand accordingly of the portfolio. So it's already operational for the stakeholders to use. A first overview for the retailers to have some basic statistics. For example, how the portfolio is distributed in at the low voltage or medium voltage contracts. They can be aggregated either as a number of customer to see visualization based on the number of customer per category, or respectively to their consumption, so that the retailer can understand that, for example, at the low voltage level, the consumption levels, for example, may be lower than on the medium voltage, and apply some different strategies. The different statistic that can be offered for every metric can be either on voltage levels, we can see right now, also per region, and at power level, information that comes from the contract, so I mean the contracted power, and also for elasticity, which means that depending on how we have seen from historical data that the customers react to any price fluctuation, how the demand actually also changes. So we can say that we can group customers based on how elastic they are at 3 different categories. Okay. This is how the retailer can see information based on the region, and perfect. For example, the bar chart is just a distribution of the customers around the country. This is from the Greek pilot. These results, and through the pie chart, the distribution of the portfolio of the low voltage customers according to their contracted power. This is the visualization for the number of customers per contracted power level. And this is what we have been talking about, the elasticity. So, for example, this is from the Spanish demo. 40% of the portfolio can be characterized as highly elastic, which means that the retailer can decide a different pricing scheme for this category of customers, so that he can control better the imbalances that occur. And when we talk about imbalances, we actually mean that If a retailer has participated in the energy markets and the amount of energy purchased is lower or much higher than the demand of the consumers, can lead to additional costs for them. So controlling the customer's demand through different pricing schemes, which is actually the implicit demand response strategy, is how the retailers can deal with these imbalances. And some general energy analytics for the portfolio. Through the big data platform that it's built at the Beyond platform, which is actually a centralized tool where all the data assets are gathered and several analytics are executed. We can use the results of the analytics for forecasts. This is what we can show here as day ahead consumption of the portfolio. But also, of course, you can use the data from the big data platform just for informational reasons and show some historical data of the consumption. For example, this pipeline that runs for the day ahead consumption is a pipeline that we have built with a deep learning algorithm, the LSTM, and we are able through an API to retrieve the forecast results from the big data platform. Regarding the different pricing schemes that can be offered, the retailer is going to have a list of the 3 possible pricing schemes: time of use, critical peak pricing, and real-time pricing. And according to seasonality and the cluster of customers, to decide which pricing scheme is going to be applied. So this is an example of time of use pricing scheme that is produced under after some optimization calculations. And and these are the possibilities for the user to choose a different cluster based on their electricity consumption and the seasonality. Similarly, actually, with the critical peak pricing, the retailer is able to choose a cluster of customers, and based on the season and the type of day, to see what could be the possible critical peak price scheme and the hours that the critical peak price scheme is going to be applied. So, yeah, here we are. Perfect. And for the dynamic pricing, what is available, because every time a new retail price is calculated, we have chose to show the last 24 hours of calculated real-time prices. The last price is always the price of the next hour, and okay, and the calculations are also happening based on the elasticity of each customer, and we move forward with some visualization of the energy market wholesale prices, just to give some extra insights to the retailer. For example, for the announced day ahead prices for the country of the demo, these are retrieved from the ENSOE platform through their API, and some historical prices. These are the previous days, but some extra historical prices are going to be available for the retailer in case he wants to compare how the market actually works between different days. And we move forward to the next tool, which is the personalized energy analytics for guidance on energy performance optimization and human-centered control automation. It's a tool built by Shoot5, which is a core partner at the Beyond project. Main goals of the tool is the energy efficiency optimization, energy savings based on personalized recommendations, and some scheduling activities for assets that are actually allowing it. It's also an already deployed tool and available for the stakeholders. And we move forward to a walkthrough of the platform. So basic characteristics of the tool include an overview of energy consumption and any savings or on energy or costs. Activated flexibility, which means that assets that are available to be moved throughout the day at a different time slot in order to save energy are characterized as flexible, and if they're actually used throughout the day for this reason, the energy and the energy saved is reported, and the activated flexibility in as a power measured in watts or kilowatts is also reported separately. So, of course, energy savings. Not every time probably a negative, meaning that we have prevented the system of energy congestion, but sometimes, of course, the energy savings will be positive, which means that we didn't manage to achieve a threshold of saving energy throughout the day. Also, an overview of the different available assets and, if possible, the way of controlling them. For example, for an air conditioning system to set a different temperature point. And some more intuitive, actually, energy analytics for the prosumer. Of course, historical data of energy and generation, forecast accordingly for demand and generation, and overall energy demands of the energy demand of the building, and of course self-consumption where generation is available. I don't know if you see. Okay. So, and yes, actually, it's sometimes very useful that the prosumers can compare how they have performed on their energy consumption and generation according to their previous performances, and also according to other prosumers. Like here, it's available for them to see how actually they can be placed among similar consumers and prosumers, actually. And this helps them to see what they can do to reach a certain level of demand and change their behavior on how they consume the energy. And as well, some recommendations on how they could do that in case they don't have any insights on that, because probably they will see that, okay, we are categorized as high consumption consumers, but how we can change that. And through the PIS application, some recommendations on what they can do based on their performance and their previous actions are provided. And we move on to the scheduler. here in more detail every possible device that can be scheduled or to use it for actuation is listed in detail. And anything that has happened after the actuation is logged and it's available for the prosumer in case there is a problem with the communication with the devices or anything similar. And this is how a schedule can be applied for device. It's pretty intuitive. And of course, every prosumer has the possibility to browse their profile and change probably some of their configuration on the apartment they are living, their devices per apartment and room. Perfect. And also some configuration over the building assets. In more detail, for example, the efficiency and the user comfort, and probably even if they don't want to mess the tool, not to mess with their devices and perform any control actions. And this is it from Beyond. Thank you very much for being here and hearing us. I don't know if you have any question or anything. I will stop sharing my screen.
Hello, there's no questions here. Thank you so much.
Thank you.
So we can end the session now. So thank you so much. That's it. Thank you.
Okay, thank you. Bye.
Thank you.
Thank
you all
you.
for participating.
All right.